Hey everyone, so I've been getting a lot of requests to break down this, like what you have to do here. So again, I'm not gonna really solve the entire thing, but I want to give you guys some of my thoughts. So I'm looking at this for the first time. We've got some data here on the left. This is obviously forecasting. You've got 1, 2, 3 years up until the the 7th month of 2023, and then you've got some additional here. Red numbers are extended data to be used with averaging techniques. Okay, fine. Use an appropriate forecasting technique to update the demand data until December of 2024. Okay. An Excel file with randomized data is provided along with the assigned paper. Okay. So the data changes every time. Justify accuracy of your forecast techniques. You need to try out at least 2 different forecasting techniques to be able to justify your chosen technique. Depending on your needs, based on the choice of a particular forecasting method, you may generate more data by copy-pasting the data provided until December 2024. Also, when you copy-paste your data into your own, you use paste number 4. Okay, so yeah, so basically, because you don't want the data to keep changing, if you select it and then you right-click, paste values, it'll just keep the values, and then it'll stop kind of randomizing the data. So that's one thing. Then based on your analysis and comparison approaches, you're expected to provide a recommendation. So basically you're asked here to compute 2 different forecasts using one of the techniques you've learned or we learned in class, and then compare them. So likely to do some kind of MAD or something of that nature. So here you have many options. I mean, you can use the naive approach. You can use a moving average. You can use a weighted moving average. You can use exponential smoothing, but you would have to pick your own alpha. You can use trend adjusted forecasting. You can use linear forecasting, right? So those are all your options. Now, it's not seasonal. You can tell because, I mean, there's no pattern, right? So it's not like, but it does appear to be trending upwards somewhat. Like, this is really low, and then it's going up, and it dips, but then it, generally speaking, it looks like it's increasing. Look at the numbers down here. So I would probably lean trend adjusted forecasting and linear forecasting. Again, it's totally up to you, but I would pick these 2 because of just the nature of the data, and how it's increasing. So I'm going to start by, I'll just copy my data here. So I have 2 of them. On this page, I'll do the TAF, so ST-TAF. And I'm going to select an alpha of 0.4 and a beta of 0.8. Again, totally up to you. In fact, you can play with these numbers to try and get a really good forecast. We'll see that a little bit later. So just like we learned in class, I'm going to set my initial S as my initial demand, my initial T to 0, and my TAF, I'm going to add these 2. Okay, so I'm not going to go over the forecasting techniques. We had a whole class on that. You should have known this for the midterm. So I'm just showing you guys how I would do it. And then I'll repeat the process. Now for S, we're going to use the formula. So we know the formula is TAF plus alpha times actual minus TAF. And I want to copy this all the way down, but as soon as I do that, you'll see that I get weird because of the cell reference. So what you should do, if you're going to be doing it this way, I'm going to make H3, my alpha, an absolute cell reference by putting $signs in front of the letter and number. That way, if I paste it down, it continues to use that same alpha. Okay, I'm just going to drag that all the way down. Then for T, I'll use my formula, which is the previous T plus beta times my S minus my previous S minus my previous T. I'll put it times there so it works. Okay. Again, I'll make H4 an absolute reference. And then I'll drag this down. And then the TAF is always the S and the T from the previous period. I'll drag that all the way down. And just basically copy this formula all the way to the last one. So now I've got my forecast. I'll move these. So now what you need is these two columns. And we're going to make an error column. Error is basically your actual minus your forecast, right? So we'll do absolute, so ABS, open bracket, demand minus TAF, close bracket. That's my error, and I'll just drag that all the way down. So these are the errors. And if you calculated the average of this, so that would be the MAD. So average error. The MAD is 2012. And what's cool about the way I did it is, if I do want to see if I can bring this MAD down just by playing with the alpha, right? So what if I made my alpha 0.6? MAD goes way down. So that actually improved my forecast. What if I went even higher? 0.9. Even better. So you can get a little bit creative. I mean, creative. You could just mess around with this. Look, if I increase my beta, did it get better? Actually, a little bit worse. So if I decrease my beta, ooh, it gets better. Interesting, right? So you can, again, play with this if you want to try and find your sweet spot without breaking your head too much. An alpha of 1 seems to do a pretty good job. And then a beta of 0.5 went up, 0.3, 0.4. That's better. 0.35. Okay, cool. Whatever, right? You can mess around with that. I get a pretty solid MAD. So that's one of my forecasting techniques. And then for the linear forecasting, you'd probably want to use one of Excel's functions, right? Which is, you can use this, LINEST, open bracket, Y's and X's. So your Y should always be the actual demand. Actually, before we do this, we're going to have to add here time and number everything. So when you're doing linear forecasting, this should all be time. This should be numbered. So I'm just going to drag this all the way down. So yeah, okay. So LINEST. The Y's would be the demand. So all of those, select them all. Comma, the X's would be time. And then you close your bracket. Okay, and that gives you a slope. Now the first number is the slope. Second number is the intercept. If you have some older version of Excel and that doesn't work, you can use the slope function and the intercept function the same way. So you would type slope, choose your X's and Y's, type intercept, choose your Y's and your X's, and you would get the same values. Then what you want to do is your forecast. So you're going to do basically Y equals mx plus b. This is your slope and this is your x. So you're going to do slope times x plus intercept. And make the slope and the intercept both absolute references by putting the dollar signs, and then just copy it all the way down. And now you get your forecast for every period. And then you're going to sort of repeat the process that we did here with the errors. So we're going to do the error. So absolute demand minus forecast, close, and then just copy that all the way down. Those are the errors. And your MAD, oops, MAD is the average of the errors. 1974. So actually quite a lot higher than how low I was able to get this MAD. And you can't really mess with this one after, so this is kind of it. So again, you don't have to use these. You could have used anything. You could have used anything I listed here. You could have just straight up used the naive approach, right? Where the sales in any given period are forecasted to be whatever you sold the period before. It really doesn't matter as long as you calculate your errors properly, you calculate your MAD, and then in your little analysis, you discuss, what's the recommendation here? For my recommendation would be to use trend adjusted exponential smoothing with an alpha of 1 and a beta of 0.35, because I was able to get my MAD down to 1,000. Under linear forecasting, the MAD was almost double that, right? The average error was almost twice as high. So your recommendation should include exploring more advanced or additional techniques in the future, collecting additional data and additional information. That's going to be up to you to kind of use your knowledge of the course and some creativity to write a nice report. Yeah, this is just how I would break down the data. All right, I hope that was helpful. See you guys.